Well, we're going to have some fun now. You ready to learn? I hope you are, because drinking from a fire hose is the theme of what I do. So I'm going to cover what's new in 3D printing and rapid prototyping. In past years, I'd used this image for A, the developments in this industry and the rapid pace of development and everything just coming at us, but also B, my presentation style and how much information I have to cover. That was the last 2 years. This year, I could use a spigot with a trickle. I could use a barren, arid desert, and we could just end this conversation right now. But that would be absolutely 100% wrong, because we're going to drink from that fire hose, and it is actually pouring more than it has in the last 2 years. What I'm going to do, as Debbie already mentioned, is cover 3D printing in terms of hardware, software, and materials, and I'm going to cover 3D scanning, specifically on materials. Now, some rules of the road. One thing I'm going to correct Debbie on: because there is so much going on, there's so much new product out there, I've actually had to limit it to items introduced over the last 6 months. I also have limited it to hardware or materials and support services dedicated to hardware that sells for above $5,000. If I dropped it below $5,000, oh my goodness, the floodgates would really open. And I've generally limited in the past to things that are commercially available or soon to be commercially available. Now, on that last one, I'm going to make an exception this year, because I believe we are entering an age of innovation in 3D printing, an age of innovation in hardware, software, and materials, and innovation for your application. So I'm going to take some exceptions and actually present to you some of the things that are in development, in research. We have no idea when they're coming. So, as Jason already gave you the overview, this is the ASTM classification of our technologies. To give you a bit of assistance as you drink from this fire hose, I'm going to be using these as icons. On slides where it's appropriate, that will appear at the bottom, giving you a little color-coded on what technology class I'm talking about. So green for binder jetting, purple, pink for direct energy deposition. I'm just using 2 initials here. Material extrusion is bluish. Material jetting is green. Orange for powder bed fusion. Sheet lamination is blue. Orange for vat photopolymerization. And HY for hybrid, that's a purple. So that's your color code, because I'm going to try to do my best to tell you what technologies I'm talking about, describe them, but I often forget. Let's get started and ease into things. I'm going to try to present you trends along the way too, group things into trends. But we'll ease into things and go with some names, some household names in our industry, and see what they've been up to. Of course, the 2 big boys in our industry are 3D Systems and Stratasys, and they've been busy. 3D Systems in the last couple of months has introduced 3 new platforms, 1 for metal, 2 for jetting of photopolymers. The first one, as the icon indicates, is powder bed fusion. Specifically, the technology is laser melting, so laser onto a bed of metal powder. The product is called the Pro X 320. This is a new architecture for 3D Systems. They already have an existing product line for metal additive manufacturing. This is a new architecture, and this machine is purpose-built for production applications. It's meant to be a workhorse that grinds through parts for your production needs. So everything about it is tuned to production. Better or easier powder or swapping of materials, better gas management, better oxygen level management for better chemistry in the parts. Builds parts. I'll try to give you the size of these things too along the way. It has a build envelope of roughly 11 inches by 11 inches by 16 inches, so bread box size. Moving along, we have 2 systems in the material jetting category. They call their process MJP for multi-jet printing. 2 products here, MJP. This is jetting a photopolymer. The first one is the ProJet 3600. This is a replacement for the predecessor, the 3500 series. Primary development in this is a 2x improvement in throughput on the platform. The next machine is a lower price point machine meant to be for more office environments. So it's tuned to the office for handling and safety and ease of use. It's also got a price point for the office, which they needed because they didn't have anything on the lower end. Now with the 2500s, you don't sacrifice a whole lot over the 3600. You get 1 choice of layer thickness versus 3. You get 2 materials instead of the 5 or 7 on the others. You get slightly less accuracy, but it's an office printer. So that's from 3D Systems, and there's one other thing I'll have later on in trends. From Stratasys, a couple of months ago, they announced this thing called Creative Colors, and I kind of went, It was about expediting the process of going from color data into the printing world of their Xjet technology, which is a material jetting technology called PolyJet, so jetting of photopolymers. And it was about taking true life colors and interpreting those into the world of PolyJet because they had a very discrete palette of colors. Well, what I didn't know is just last month, they had up their sleeve the announcement of the J750 pictured here. This is a multi-material, multi-color printer running about 19 inches by 15 inches in XY build area, up to 360,000 color combinations, shades, hues, opacities, and also the multi-material combination. It's got brand new print heads, got brand new software. So it's big, it's powerful. And this one I should actually show you a picture, but I decided to tease you, make you go see parts on the floor, because you will be impressed when you see these. Oh, by the way, to assist you, you see the numbers next to Stratasys in 3D Systems name? That is booth number for the show. If there's a number next to the company name, that means they are here at Rapid, and if you find something interesting, you can go check it out. The other point on this presentation is I'm not here to teach you all the details on these. I want to give you enough to understand the landscape, what's going on, and whet your appetite to say, you know what, that's something I should investigate on the show floor or after the show closes. Sticking with the companies that have been around in our industry for a while, we have EnvisionTech. It's best known for DLP-based technology. So that is a vat photopolymerization technology using a DLP chip, just like you would do in a projector, projecting these PowerPoint slides, but that projects a mask of light, which cures the photopolymer. Now, the first one on this list is not DLP-based. It's actually their own unique process called 3SP, which is a alternative take, an alternative spin on the classic laser-based stereolithography. They use a laser, but they use spinning mirrors and all these other things. They call it 3SP. They introduced the Vector 3SP. This is merely a product line filler. They already had the Ultra on the low end, and they had the Exceed and the Extreme on the high end. They were missing something in the middle. So this is mid-size, mid-capability, mid-price point for you. They also introduced the Micro Plus. This is a small unit, stands, maybe 19 inches tall and about 8 or 9 inches wide and deep. So this is a very small DLP-based printer. Here, the improvements from the prior Micro line are some cosmetics, in introducing touchscreen, introducing an integrated computer and Wi-Fi, and upping the speed and accuracy. Now, one that was announced at CES in January caught me by surprise. MCore Technologies, we saw the orange when Jason had his presentation. This is a sheet lamination process, laminating sheets of paper, adhesing them together, and then using a cutting instrument to cut the profile to relieve each layer. Well, they've been known for high-fidelity, photorealistic 3D printing for a number of years with a product called Iris, which sells for between $40,000 and $50,000. I mean, full-color, high-resolution printing. They turned around and came out with this thing in January called ARC, and I believe it's available today. It's called ARC, and it's a complete redesign of the machine. It's a complete redesign of the process. Instead of sheet-fed paper, it's roll-fed. The cutter assembly changed. Everything under the hood changed. So they're giving you more with a more reliable package and at a hugely discounted price point. What was over $40,000 now sells for $6,000. So you can get full-color, photorealistic parts with a wood-like characteristic. Now let's get into trends. One trend is bigger. This trend has been going on for a long time. We've got some big, big machines. But again, I'm limiting it to things in the last 6 months. So these 4 examples are those that have made announcements in the last 4 months. The first 2 are material extrusion. And this is showing that we're going from the desktop, consumer-oriented small machines, getting bigger and bigger, pushing into the professional world, and getting to a size where parts are measured in meters. I should say singular, meter. First one is Titan Robotics. They announced a product called Atlas 2. Its build volume is 1 meter by 1 meter by 1.2 meters, so that's roughly 3 foot by 3 foot by 4 foot. They've built this thing to be industrial. They call it bomb-proof, and it sells for all of $24,000. So you have a bigger alternative. Likewise, we have 3D Platform, also material extrusion. Oh, the other thing I'll do throughout this is I will use the terminology FDM to describe extrusion of thermoplastic through a nozzle. I can do that today because Stratasys has relinquished the copyright or the trademark on FDM, but I cannot say fused deposition modeling because that is a trademark term. So I'm going to use FDM as a generic. 3D Platform came out with a new system called Workbench, and you can see why they're calling it Workbench. This thing can fold up, go through a door, unfold it, and you've got an integrated workbench. Its build area is 1 meter by 1 meter by 1/2 meter. Don't know a price point, but you see the two differences. The Atlas was a closed, controlled environment, thermally controlled. This one is open to ambient air. We also have big, not just in FDM, but also in the, you know what, I don't know what to call this one. You'll see why. This is a photocurable material. The company's called Massivit. The machine is the Massivit 1800. The machine has a build volume of 4 foot by 5 foot by 6 foot, and it can build at a rate of 6 feet, vertical feet, in 5 hours. That means that you could reproduce someone my size in about 4.5 hours. That wasn't funny. You weren't supposed to laugh. So it's a very, very rapid process. Now what they're doing, they call it gel dispensed printing. They are extruding a photopolymer as a paste-like gel and then hitting it with UV light to cure it. So I've slapped on the material extrusion label here from ASTM, but I'm not quite sure that's what fits. I'm starting to see that ASTM is going to have to expand some of its definitions or expand its categories. Another one I have on here is services only. You cannot buy this, but it demonstrates bigger, and there has also been an announcement in the last couple of months. The company is called Norsk Titanium. It's out of Europe. They have their own technology that they sell parts off of. They won't sell you a machine that'll make titanium parts measuring 4 foot by 7 feet. So up to 7 foot long. The process is plasma-based. Rapid plasma deposition is what they're calling. So it's basically a plasma welder with a third dimension added. Now the reason I've got them included here, even though you can't buy a machine, is they just had an announcement, two announcements. One, they're partnering with Alcoa to do a little technology transfer to advance the technologies. And number two, they've just reached an agreement with a U.S. company called Precision Holdings that has contract manufacturing interest. So you have the ability to get titanium parts through a contract manufacturer here in the United States, even though you cannot, because this company is European, even though you cannot get the machine. And also, in Europe at least, their parts are prepared to be certified flyable in 2016. So we have bigger, but we also have faster. And boy, Carbon 3D really opened Pandora's box. Anyone recognize the name Carbon 3D? Okay, first off, they've changed their name to Carbon, dropped the 3D. About a year and a half ago, they appeared on TED, in a TED Talk, talking about the technology and mentioning 100 times faster than anything else out there. Lightning quick. Well, last month, early April, they introduced their first machine. It's pictured here. It's called the M1. M, I thought, stood for Machine One. I thought they really had bad marketing, but it actually stands for medium. So they're planning on a product line of small, medium, large, and other. This has a build area of about 3.5 by 5.5 inches, 13 inches tall. What gives it its speed, and it's a process called continuous layer interface printing, or CLIP. What gives it its speed is, well, let me back up. It's a DLP process like so many others, so light is flashing. It's that photopolymerization, but they're using a problem in the chemistry of photopolymers to their advantage. Photopolymers don't like to kick off, don't like to cure when they're exposed to oxygen, high oxygen content. They're turning that around and creating a dead zone with high oxygen content that allows quick release, which allows them to basically run that DLP projector at 60 frames a second, so it gives you the illusion of absolutely no layers. You can physically see the parts drawing up. So they released the product. They changed the business model a little bit from everyone else. It's a lease program, 3-year lease to enter in. I believe it's $40,000 or $43,000 for this. It's very exciting. Oh, and the machine is robust. Lots of sensors and all that. Pre-calibrated at the factory build plates, that when you put it in the machine reads the build plate and adjusts accordingly. Feeds all kinds of data via the internet for machine control and monitoring. But what I really, really like is if you talk to them, they won't talk speed. They'll talk materials. Because of that speed, they're able to use photopolymers heavily loaded with thermoset materials, which opens up the door to a whole new range of chemistries. Right now, they've got 7 materials that include high heat, high strength, high flexibility, things that we don't have in the other vat photopolymerization categories. But close on their heels, other people wanted in on this fast game. A company called NewPro 3D was at CES in January, claiming we are the fastest 3D printer, even though they don't have a machine, haven't decided if they're going to make hardware or sell licenses. They don't know which direction they're going to go, but they're claiming we're real fast. They use a process they call Intelligent Layer, ILI, Intelligent Layer Interface or something like that. similar to what carbon's doing. However, they're using a membrane and they're wetting that membrane, and that wetting agent is what inhibits the curing and creates the dead zone. Right on the heels of that, within weeks, Nexa 3D popped up, announced a machine called NX1, which sells for, is intended to sell for less than $2,000, run about 3 minutes per vertical inch of part, so rapid. They want to be fast, but these two guys got in a little bit of a battle over IP, who owns the IP and who stepped on whose battle. They were supposed to deliver product in March 2016, so last month. Went to the website to get an update. It still says March 2016, so they've kind of retracted. I don't know where they are. I don't know if you'll be able to buy this anytime soon, but it's a desktop unit, $1,800, runs lightning fast. Also along the way, a company out of Korea who's been in the DLP game for quite some time, Karima, has a technology that's also fast. They call it CCAT, for Karima Continuous Additive blah, 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 blah. This process, they don't tell you how they're doing it. I'm assuming it's the same strategy. They're better positioned to roll out a product than the first two that I mentioned because they've already shown, they've already been through beta, they've already shown the product it shows, and they plan to release it in 2017. So another speed solution based on photopolymerization. But we still have more. We've got Structo. Structo has a product called Rapid Form. There's two others, smaller versions. This thing has a build area of like 16 by 14, so they're bigger parts. Runs quickly. I think they're talking 2 to 5 minutes or 2 to 5 seconds a layer. Now, what they're doing different, and I don't know how to categorize this because I can't say DLP anymore, they're using an LCD screen, liquid crystal display. So you use a light source, illuminate it through the LCD. The LCD forms the mask, and what that gives you is the ability to manipulate the process a little bit, but also can reduce the price because LCD screens are much cheaper than DLP chips. So there's a possibility to scale up more. Photocentric is also using LCD. Now, they're not going after speed. I shouldn't have them in speed, but since I was on the LCD line of thought, I thought I'd stick with it here. Photocentric is a company that makes photopolymers. They call their process daylight polymer printing because they're using ambient light. They're not using UV light sources, but they are using a liquid crystal display. That combination is giving them speeds comparable with DLP, which is a bit surprising because when you get away from the UV light sources, it takes a lot of energy to kick over these photopolymers. And then finally, this one's in Kickstarter. The company's called Uniz, and the product is called Slash. So it's looking at being 50 times faster than traditional vat photopolymerization technology, so it's not a comparison to carbon and the others, but it is, they're claiming to be much faster than the status quo, and that product is going to sell for less than $2,000, and I'd be absolutely surprised if it doesn't make it to the market because they've had a hugely successful Kickstarter campaign, like 10 times over what they're asking for. And we're still not done with faster. 3D Systems isn't going to be left out. Now, this is a product demonstrator. Don't plan on buying this tomorrow. Don't plan on buying it next month. I don't know when it'll come out or if it will. It's likely to come out. I'm assuming, even though they don't talk about it, I'm assuming they're doing the same dead zone concept, vat photopolymerization, DLP. At CES in January, they showed it in a form they called SLA Bot 1. And SLA Bot 1 was the imaging, a tank, and then the resins, highly reactive resins, which also can be loaded with thermosets. But they were using an industrial robot to give you your Z stage, your indexing. So the robot was pulling the platen. A month ago, at Additive Manufacturing User Group Conference, they showed SLA Bot 2, the second iteration, and they're calling it Figure 4. So there's two names that it goes by. Figure 4 is a reference to the patent, an image, an illustration in the original patent by Chuck Hull for stereolithography that gave birth to this whole industry. Another trend, even though I only have 3 here, it is a trend, is the concept of hybrid. For us in the industry, hybrid means a combination in the same box, the same machine, of both additive and subtractive. I've got up here also multi-tech because it doesn't necessarily have to be additive and subtractive. It could be additive and additive. The first one is a company called Fuse Machine. This is a desktop, prosumer grade machine called Orsis. They call their process dual sculpting technology, selling for somewhere, I think it's less than 5,000, but definitely less than 10,000 desktop device. What they're doing is FDM, so extruding plastic. It's a material extrusion process, and combining that with in a tool changer mode with a cutter. So deposit a little bit, cut a little bit, deposit a little bit, cut a little bit, have a finished part come out of the machine. They're not the first ones to do this, even on the desktop machines, and they won't be the last. They just happen to be one that fit my parameters of this time frame to report to you. This one is very new, and they've been somewhat visible, but fairly stealthy. The company is called Rise, and this is the multi-tech example. What they're doing is combining material extrusion, FDM, with jetting. They deposit a thermoplastic, follow that by a jetting of an agent that changes the characteristics of the thermoplastic. Their machine is going to be called Rise 1. It should be going into beta shortly this year. And with a little bit of luck, maybe we'll see commercial version end of this year, sometime early next. You can stop by and get more details on that. But what they're doing with their first version is delivering it with their own custom thermoplastic called Risium 1, which they're not saying what it's like. They're not doing it's ABS-like, it's polypropylene-like. It is a thermoplastic, they're just not naming it. It's a good thermoplastic, nice and rigid, nice and durable. They're combining that with two agents. One is for support release, making very easy release of support to part, and the other one is to increase bond strength. They state that they're increasing the bond strength to a point where it's 100% better than the status quo and a material called ABS Plus from another vendor's commercial systems, and moving towards isotropism, giving you the same tensile properties or mechanical properties in X, Y, and Z. They also can use color agents. Right now it's grayscale to add text, add texture, and add images on your thermoplastic part. Jason Jones, who you saw up here. His company, Jason, your company name is just way too long. I had to abbreviate it. Sorry about that. Hybrid Manufacturing Technologies has been in the industry for a couple of years with a commercial solution called Ambit. Ambit is a tool changer concept where you can put some cutters on the tool changer, you can put a probe or two for inspection, and you can put an additive manufacturing tool in there too. To date, that additive manufacturing tool has been based on laser cladding or blown powder or laser metal deposition. So as he showed up on the illustration earlier on, generate a melt pool, blow powder into it. But got an announcement, and with a little bit of luck, we'll release it commercially before the end of the year. Adding to the Ambit arsenal is a material extrusion head that you're seeing here. So now we have FDM as another opportunity to put in this tool changer, which you can add to used CNC mills or CNC platforms or new CNC platforms. With this, they partnered with Oak Ridge National Labs, those who created something called BAM, Big Area Additive Manufacturing, which its commercial interpretation builds parts out to 12 foot long and deposits up to 100 pounds of thermoplastic an hour. Now, Jason isn't shooting for that. Hybrid Manufacturing Technology isn't shooting for that. What he does say is somewhere between that upper threshold and what the commercial systems are doing today with FDM, that's where he's going to be. So it is going to be a high deposition rate solution. The other thing I really, really love is he's keeping the BAM principle of feeding this thing, not filament, but feeding it pellet. Pellet that you pull from your injection molding supply chain, which means pennies per pound, or dollars per pound, instead of tens of dollars per pound. Other trend, as Jason already indicated, metals, 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 metals. Everything seems to be metals. I'll ease into this conversation. EOS, a leader in metal additive manufacturing, using powder bed fusion, specifically laser melting, so laser in a bed of powdered metal, came out with a introductory entry-level system called the M100. 100 millimeter diameter build chamber, 200 watt laser, limited to 3 materials, but there are no slouches, titanium, cobalt, chrome, and a 316L stainless. Arcam came out with 2 additions or 2 upgrades to their existing Q10 and Q20 platform. Arcam is also powder bed fusion. However, its process is called electron beam melting. They're replacing the laser with an electron beam, which is higher energy and moves much faster. Their improvements here are going after throughput and part quality, improving overall production, decreasing production time by 25%, improving surface finish, and improving overall quality of the part. The way they're doing that, number one, introducing something called XCAM. They're using X-ray detection during the build process for calibration and monitoring. They've also changed their software and incorporated new electronics. Renishaw, another long-term player in the metal additive manufacturing field, has come out with two new platforms. One is new from the ground up. The other one is built off of an existing platform. Both of these are powder bed fusion. Both of these are laser melting. First one is the Ren AM500M. This is the brand new platform from the ground up. Lots of things that were designed and built by Renishaw, which is a primo company that's very well respected in the manufacturing realm for metrology solutions. But new optics, new powder handling, new sieving capabilities, and dual filter. They call it safe change, where you can swap out filters while the machine's running. This machine is purpose-built for production, and it's intended to be run with only one material. Not that you can only pick between one material, but the intention is load it with that one material and run day after day after day after day, kicking out production parts. The AM400 is built off of the predecessor, the AM250. This keeps the same size, same cabinetry, but improves the optics, improves the spot size of the laser, bumps the laser up to 400 watts, so it's giving you a more robust solution in the same footprint. Here's an exciting one. I'm really excited to see this one born because I've been associated with it for the last couple of years. Xjet, they will be on the floor. You are in for a treat because this is the worldwide launch of a brand new technology. It's called nanoparticle jetting, and they will be showing you metal parts that have basically been ink jetted. The machine shown here, I don't even know the name of the machine yet. I don't know how big a build envelope it has. I don't know a price point. But what the process does is it jets a combination of a carrier and sub-micron powders, metals, jets them in small droplets, hot envelope, hot tray, and the carrier evaporates, and the metal powder bonds together. Now, it's not usable right out of the machine. You will have to put that through a furnace cycle to get full sintering on that. But what they're going for is high speed, high resolution, high detail, high surface finish. I highly recommend you stop by their booth and see what they've got. Also, they aren't just new to the industry. This company was born by those that started a company called Xjet, which was acquired by or merged with Stratasys a number of years ago. So they've got experience. Continue with metals, and there's a sub-trend here. All four companies on this slide are traditional machine tool companies. So the machine tool industry is coming to 3D printing. It's already here, but it's coming more and more every day. The other sub-trend on this one is we are borrowing the heck out of traditional manufacturing processes. For example, Muto, value arc. That name comes from the use of wire arc welding. Add the third dimension, voila, I've got 3D printing. So this is about high deposition rate, about 4 kilograms per hour, multiple materials being blended in the same part, having a wider material selection, because basically if you can wire arc weld it with it, you can use it for 3D printing. Hermla, metal powder application. That's not a name of a machine, that's the name of their process. Big machine, this one's hybrid. It is directed energy deposition, but in a totally different way. They're using thermal spray, which is atomized metal powder, ejected at high velocity, maybe using HVOF or plasma to just fire it in a semi-molten state at a substrate. It's used to coat many of your engine aircraft components for wear and fretting and all that. Now they're turning that into 3D printing. It's hybrid because they've also got CNC milling incorporated on the same machine. Toshiba, all we know is they're going to be doing the laser metal deposition. All we know is they're targeting 10 times throughput increase, and that they are promising on bringing a machine to the industry in 2017. We've got an image here, but we don't have any other details, but it's going to give us another solution. It's also another machine tool manufacturer. And finally, ELB Schliff with mill grind. Hybrid platform. What they've done, mill grind is their standard platform for CNC grinding machines. That's their product name. Well, they've added additive to it. They didn't develop their own technology. They actually licensed Jason Jones Hybrid Manufacturing's Ambit technology to put on this. So we have yet another solution. And metals continue. Trump was in our industry years ago. Trump owns a lot of IP that's under the hood of metal additive manufacturing machines. Trump has now come back into the additive manufacturing industry as a supplier of machines. Two platforms. One is laser melting based, and the other one is directed energy deposition based. TruePrint is the laser. TrueCell laser is the one based on directed energy deposition. TrueCell laser gets up into like 3-foot long parts, so larger build envelope. But the question you want to ask is, why would they launch two at the same time? That's because what you need to recognize is most of these technologies aren't interchangeable. You want to use laser melting for some things, and you want to use the laser cladding for others. So they had to bring out two solutions to satisfy the market. Aurora Labs, this one, I don't know if I quite trust yet. But anyway, they're claiming that, well, they're taking pre-orders for a machine, S-Series they call it, desktop metal additive manufacturing, directed energy deposition. I actually put powder bed on there. They're being very nebulous on how they're going to do it. They claim world's first and no one's ever done it this way, but depending on the way you read the literature, it seems like it could be directed energy deposition or powder bed. But they're looking at a cabinet top, so a larger machine, but a cabinet top machine for $43,000. The company has been, if they're in the room, they'll probably shoot arrows at me, been a little flaky on their promises and pulling back from things and changing what they're going to do. So you don't know what, I wish them luck. I hope they do it. But one of their offerings is called S-Titanium. So they're looking at doing desktop titanium parts for $43,000. Sayaki, this is not a machine. This is a closed loop control system called IRIS, Interlayer real-time inspection sensing and inspection sensing system or something like that. This is added to their EBAM, electron beam additive manufacturing tools. They've got a lineup of, I believe it's 7 machines making very large parts using electron beam welding, adding the third dimension. This is about closed loop control. It's controlling the process, and that's another trend which we desperately need. What's going on as we're building these parts? Take control of it, be able to influence it before problems happen, or at least know that problems have happened so you know whether you have a good part or a bad part. So we're looking at closed loop control for everything from geometry, material properties, microstructure, the whole gamut. And then Phonon. This is a Florida company. It didn't surprise me that they're here, that I haven't been able to put my finger on quite yet, and I'm looking forward to seeing them down the show floor. The company's got a lot of experience. They do laser welding, or laser marking, laser etching, a lot of patents portfolio, claim that they can do more with laser melting than others, but it's been focused on building custom machines to date. It looks like they may come out with I can buy this unit along with custom machines, but I want to go to the show floor and see what they've got. They claim they can build metal parts up to 5 foot to 10 foot, but they also have smaller build envelopes. So I want to get down there and see what they're all about, but it is another solution in the laser melting category for you. And finally, the last two, these two are both research. Cytosurge, using micro pipettes and electrodes for micro metal parts. Right now they're working with copper sulfate, hit it with an electrode, and precipitate out copper to make a metal part. So very, 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 very small parts. Research, you don't know when it'll happen, but showing you the breadth of what we have in solutions. And this one got absolutely nothing to tell you about. This company is on the tip of many people's tongues. They've gotten a lot of attention. They've gotten a lot of investment, including Stratasys is investing in them. All the world knows is they are planning to do desktop metal additive manufacturing. We don't know how, we don't know what price point, we don't know what materials, but there is a huge amount of interest. I don't think we'll be waiting years and years and years. I get the sense that we might be waiting a year or two before we see something from them, but more opportunities should be coming. That slide's a little tease for you. All right, for 3D scanning, thank you, Michael Raphael with Direct Dimensions. He's the one who fed me these. What's new in 3D scanning, because I can no longer track this industry. There's just too much going on in both. Laser Design has a new system called CyberGauge 360. They describe it as a microwave oven for 3D scanning. Place a part in the unit, no fixturing required, close the door, hit scan, ding, it's done in 3 minutes. Capture 3D came out with a big system called ScanBox Series 7 and Series 8. I got a picture of a car body there because it's capable of doing parts that large. Multi-axis motion, vertical rails, horizontal rails, rotary tables and all that, so they can get the inside and outside of that car interior. Faro, the Cobalt 3D Imager. This is a blue light, structured light scanner. What I find very interesting on this is onboard processing in the scan data, but also a smart sensor that allows it to talk to the other ones, to other Cobalt scanners, which allows multiples to be controlled by the same computer. And Creaform with the MetroScan and HandyProbe Next, both of these are walk-around scanning devices. They're about better ergonomics, better accuracy. In the case of the MetroScan, which is the ball-shaped one, 12 times faster, or 12 times more accurate, no, 12 times faster, and working on black surfaces, reflective surfaces, and colored surfaces. Shining 3D came out with a multi-purpose scanner called Einscan Pro. It can be handheld, it can be mounted on a tripod, it gathers color. Solutionix, this will be referenced by, or shown at booth number 951 from eQuality. 2 products, RexScan CS2 and RexScan DS3. Both of these are on the, I'd say, the lower end of scanning. Affordable solutions, meant to be compact, portable, easy to use. Basis Basis Software came out with 2 new models of their hemispherical scanning. This is room size scanning. The Model 10 is able to do scanning up to 110 meters at submicron accuracy. The Model 75 has a meager 2.5 meter, about 10 feet. So both of them large range scanning. And Wenzel has announced a price drop on their Xjet CT, or Xjet M, which is a CT scanner. They're saying the motivation is to get you, the 3D printing world, to consider CT scanning more to use it for your inspection. So 25% price drop on that machine. They are on the show floor. For software, we have Solid Thinking with Inspire 2016, some new tools and upgrades in that. It's not a CAD tool, it's a CAD edition. Likewise, ANSYS with their Space Claim, not a CAD tool, it's a CAD edition. Has new tools in their latest release, and a new player called an IntegrityWare with Cyborg 3D. These are standalone packages for about $500 each that'll go from mesh to NURBS, from NURBS to mesh, and repair STL files. And Materialize has come out with suites, both for the industrial world and the medical world, that tie together all their software for a seamless backbone and let the data flow from start to finish all the way through the process. Ono has a tool for expanding the use of your CAD data. It's more of a sales and marketing thing, but I'm including it because it could be expanded to include evaluation of a file on an Apple or an Android or an iPad, and then use that in your development and then possibly 3D print it. Senvol with Senvol indexes, this is something you should really take a look at. You know, it's usually expensive to qualify materials. Traceability, using accredited labs, documenting every parameter, documenting the machine, documenting everything, and giving you mechanical properties and thermal properties and other properties of the materials. And 3D Sim is all about predicting the currently unpredictable. It's using physics-based simulation to figure out what's going on inside of a laser melting or a metal additive manufacturing machine. ExaSim helps you predict what's going to happen with stresses and distortions so you can support it better. And Flex is used to try new parameters, new procedures, new material formulations, and see what happens as the outcome in a predictive state. Another trend is automation. I've kept the same picture here because Additive Industries, which is now in beta with their machine called MetalFab 1, is the first partner with 3D Sim for their product. They're embedding it into their Additive World software. Their concept is to tack these modules together. So start with laser melting up to 4 chambers and feed that through powder handling, feed it all the way through to furnace cycle. Concept Laser also is looking at automation. They're calling theirs the factory of tomorrow. Instead of tying all these modules together, they're looking at freeing the modules and sending them all across the shop floor and having robotic transportation, moving a module from powder feeding to 3D printing to powder to depowdering and into the furnace cycle. But automation doesn't have to be limited to the big in the metal. It could also be a desktop machine from NV Bots, FDM, material extrusion, with automated part removal. So feed parts via the cloud, automatically queued up, and it automatically removes the parts. Materials will just be highlights on these. Somos introduced Element, which is specifically for investment casting, looking at predictable quality for your investment casting patterns, also minimizing ash, which is critical for investment casting. HR Labs came out with a pre-monomer ceramic. Load this in a machine like a stereolithography, vat photopolymerization, and it actually becomes a ceramic as you're making your part. This version that they have right now, up to 2,500 degrees F, it can withstand. And VisionTech, for their 3SP line, which is vat photopolymerization, came out with a polypropylene-like material called Polypro Max. Lithos came out with, Lithos is DLP for ceramics. They came out with 3 new materials, 1 for cores for investment casting and 2 that are biocompatible. Vertex Dental came out with NextDent, I think is the line. This is interesting, it's for DLP. We've always had short-term duration exposure from these kind of technologies and those materials. They've got a new line of materials that are much longer exposure, crowns, bridges, and splints off of a DLP system. Prodways came out with the TPU, thermoplastic urethane, for flexibility on selective laser sintering, which is a powder bed technology. Toray came out with, this is the product name, Tormaru, I think is how you pronounce it, but this is a PPS, polyphenol sulfide, is that correct? But good chemical resistance, good thermal resistance, good mechanical properties, and it is running on a machine called from Aspect out of Japan. DSM. I put 521 on here. I might be getting into trouble. Somos, who I already named, is a brand of DSM, but DSM announced that they're coming out with filaments for FDM and didn't mention Somos, so I'm sending you to Somos' booth because DSM isn't here, and there might be a little war going on. But anyway, they came out with two filaments. One is a PA6 based, and one is a thermoplastic copolymer. And both of them claim they have better adhesion than ABS off of other machines and platforms with better mechanical properties. Graphene 3D Labs came out with a magnetic PLA, so ferromagnetic PLA. Essentium Materials is co-locating with Cosine, which is a large format FDM machine. They've got new thermoplastics, they've got some filled materials, and they've got some other exciting things up their sleeves. Z3D Lab, this is for laser sintering, powder bed fusion, combination of titanium and zirconia, or ceramic. So a ti-ceramic combination, get the strength of ceramic, the malleability of titanium, the strongest material they claim off of a laser sintering machine. Robos, this is a desktop platform. High temperature though, they're able to process PEEK and PEI, polyetheramide. Very high temp materials that currently are only processed on machines that sell for $350,000 up to over $800,000. And Nano Dimension didn't belong here. I didn't know where to put them though. This is 3D printed electrical inks for printed circuit boards. Honorable mentions, they didn't make the cutoff of what I was allowing to cover, but I will mention them here. Just for a quick reference, Impossible Objects with booth numbers here. This is CBAM, carbon-based additive manufacturing, so it's sheets of carbon material bound together. Fusion 3D has two machines, desktop machines in the FDM category. The Lowell's Bot from the left for less than $2,500 is here. Union Tech is being represented by RP Support America. This is a Chinese company out of Shanghai with a stereolithography machine, big stereolithography machine that's now available in the United States. And then another one you probably recognize, 2D is coming. So metal machine tools are coming. 2D is coming to the 3D printing world. We know HP is coming. They've already told us they're going to have a product by the end of the year. No other details. Canon said they're coming with some lamination resin-based machine to go after speed, throughput, mechanical properties. No details. Well, Canon, there's a machine, but we don't really know, haven't seen it. Ricoh came out, but they're private labeling a machine, a laser sintering machine out of Japan from Aspect. So they put their name on it and their tweaks. Fuji and Epson both claim that they're going to be in the industry in 4 or 5 years. Fujifilm is here in booth number 562, but I have no idea if that's associated with the Fuji that's saying that we're going to be 3D printing machines, so I threw it up there so maybe you can go harass them. And Xerox finally said, we're going to get into the 3D printing industry because we see it as transformative. It looks like their focus may be 3D printed electronics, though. R&D and innovation, I'm going to wrap up with this just to show you tip of the iceberg. These are things that aren't commercially available now, nor may never be. But we have biomedical represented here. We have construction represented here. We have optically transparent glass. We have multi-axis imaging at the same time. We've got alignment of fibers through ultrasonics. There's a lot of things going on. And maybe even the last one I threw up is for giggles. Maybe our solution is going to be a $99 3D printer where your smartphone becomes the imaging device. That's Olo, which is in Kickstarter. So what's new, ladies and gentlemen? A lot. I know I threw a lot at you. My intent was not to teach you, but instead to intrigue you. Probably have your eyes crossed, maybe a little bit of smoke coming out of your ears. But with that, I hope you're enjoying this because it's the tip of the iceberg and there is more to come. I know there's at least one press release tomorrow or press conference tomorrow to announce a new product. I would not be surprised if there's more here at Rapid because this is a launch event. So if you have access to the news tomorrow morning, Wednesday morning, Thursday morning, I'd read up on that because there will be announcements, I guarantee. So with that, run down to the show as soon as the doors open tomorrow. Go see these booths, check out the new technologies, and enjoy the ride. Thank you very much.